So good day everyone, my name is Duff Mananghaya and I am from INF 214. So in this video, I will be tackling about the two chapters in our lesson in Mathematics in the Modern World, which are, the first one is Mathematics in Nature, and the second one is Mathematics as Language and Symbols. So based on our lesson in the chapter 1, Mathematics functions as Mathematics as a pattern, Mathematics in Nature, and the Fibonacci sequence. So let us begin with the first one, Mathematics as a pattern. So let me give you an example to further understand this matter. So the first one is, a kid notices that when skip counting by 5, the next to 5 is 10, and the next to 10 is 15. Another example is, a weather forecast that is based on atmospheric patterns. So basically, in order for us to understand things better, we must analyze and distinguish its pattern. So the another subpart is geometric patterns. So typically, geometric patterns is very applicable in the field of arts. For example, if an artist creates a painting with a pattern of a diamond, the official shape would be diamond. So the last subpart in this function is the word pattern. When we are asked to determine this example, if swim is to swam, then sit is to sat. So in this case, we determine the past tense of a certain word. So the next function would be Mathematics in Nature. So the famous painter Leonardo da Vinci and his famous work, The Vitruvian Man, proved that in his painting, he uses symmetry and proportion that is relatable to math. So wondering, how does it work? So Da Vinci's inspiration is a pattern. Da Vinci said that only humans can make these kinds of formation that is thought to be an intelligent design. So the same goes as nature also embodied. So the famous painting of Leonardo da Vinci, which is the Vitruvian Man, is also an example of bilateral symmetry that is common in animals and humans. So this is an example of bilateral symmetry, which is a starfish. So the last but not the least function of mathematics is the Fibonacci sequence. So the Fibonacci sequence is named after Leonardo of Pisa, also known as Fibonacci. He primarily discovered this idea by analyzing the group of rabbits which are reproduced and bred. So to further understand what Fibonacci sequence is, let me give you an example. So when we have a set of number that is consists of 1 and 1, and then by that, we should add the two terms. After adding the two terms, we will have 2. And after that, we add the last two terms, which is the 1 and the 2, then we have 3. The process will repeat, and so on and so forth. So technically, Fibonacci sequence can be expressed as xn plus 2 is equals to xn plus 1 plus xn. So in a nutshell, in chapter 1, which is Mathematics in Nature, I learned how math really works in everything, most especially in our daily life. So let us now jump at the chapter 2 of our lesson in MMW, which is Mathematics as Language and Symbols. I believe that even in language, mathematics can also be applied. For example, when it comes to terminologies, mathematics can also be applied. As I have said, when I say double the value, we can say multiply. When I say how long that certain object is, we can say its length, or its width, or probably its height. When I say cut it into halves, instead we say divide. So in this case, mathematics language can also be used to further understand in all situations. But take note, mathematics language can also be confusing because some words that is used in mathematics is also present in other fields. For example, the trigonometric function sign can also be confusing because the sign spelling, which is sin, is also present in the terminologies in religious, which is sin. So it is very confusing if we don't analyze it properly. So, for example, the pi, which is used in circle. Pi is is literally the pie that we consume, that we eat. So in other cases, it can be somehow confusing because other terminologies in mathematics is used in different fields. So in the other subparts of mathematics as language and symbols is the expression versus sentence. So what is expression? Expression is a mathematical analog derived from an English noun, and it is also a proper and correct arrangement of certain symbols that is used to represent a mathematical object of interest. For example, number, matrix, function, and many more. While we say sentence, we are pertaining to the arrangement of symbols that aims to tell a complete thought. Just like in English subject, which pertains that sentence should contain a subject and a predicate. So the example of sentence in mathematics are true, false, and many more. And again, let me give you a concrete example. So in English, we can simply say driver. But in math expression, we can represent the driver with an X or with a Y. In English, we can say the profit minus investment. But in math expression, we can say X minus Y or Y minus X, and many more examples. So to add, I also learned that mathematical language is meant to be precise, concise, and meant to be powerful. So first one, why precise? Because it has the ability to distinguish or define a set of mathematical symbols with extreme precision. So second one, concise. Why concise? Because it employs the language of mathematics to explain otherwise long expositions or sentences in a concise manner. So technically, mathematical language can summarize. So third one, powerful. Why powerful? Because it can express a wide variety of expression in an ease. So to add, mathematical symbols can be used in different fields. It can be used in different branch of sciences such as in programming, computer science, and many more. Next in line is what we call logic. Why is it important? In and out of mathematics, logic permits us to determine the validity of arguments. It also emphasizes the importance of mathematics language, precision, and conciseness. In relation to this, we have what we call propositions. So ever heard about propositions? So what is propositions? Propositions is a declarative sentence that can be declared as true or false, but not both at the same time. There are other types of sentences where true or false is not acceptable, and that is called paradox. A paradox is the unpredictability of a mathematical conclusion despite the fact that every step in the argument is legitimate. So in propositions, we have different kinds, the simple and the compound. Let us begin first with simple proposition. So simple proposition is a proposition that conveys one thought without connecting words such as and or or. Example, Iris is good at dancing. John is good in swimming, and many more. So let's go now with the compound propositions. So what is compound proposition? Compound proposition contains two or more simple propositions that are put together with the use of connecting words such as and or or. For example, Mary lives in Tarlac and Jojo lives in Laguna. Words that make up a compound propositions are called component statements. There are 5 different kinds of compound propositions. First one is the conjunction. Conjunction usually uses and, A and B, to express a statement. Example, Korea have Hangul and Philippines have Tagalog. Number 2, disjunction. It has 2 subparts, the inclusive and the exclusive, and it usually uses or, For example, in inclusive, I will ask money from dad or I will work for my own. Example of exclusive, I am either COVID-19 positive or negative. The third one is the conditional. The conditional usually uses the if-then. Example, if mom doesn't allow me to come to the party, then my brother can't go also. The fourth one is the biconditional. The biconditional usually uses if and only if. Example, the polygon has only 4 sides if and only if the polygon is a quadrilateral. The last one is the negation, based on the word negation, which is you negate it to a negative side. So if the given statement is true, negate it to false, and vice versa. Example, I am feeling good today, so negate it. I am not feeling good today. So from feeling good to not feeling good today. In conclusion, what we have in chapter 2 is a solid application of mathematics in language, and of course, its symbols. Mathematical language and symbols are very essential for us IT students as it may help us to execute our code in different programming languages. Before doing this task, I first recall all the lessons both from chapter 1 and chapter 2. And after that, I take note all of the important terms that I need to elaborate. In this task, I do it myself because I think it is convenient for me to do a report even on my own. Fortunately, I just recovered from my fever and cough while doing this task. I think the challenge would be how can I balance the time for me to gradually do this task even in time of suspension of classes.